Before we talk about the parts of a C program, I want to talk about how we go from the C program code down into the C program, the executable. So you're going to start off when you write a program creating some kind of file called program.c. And you're going to, when you want to create your executable, first you send it through a preprocessor. And this processor was going to strip away parts of the code and make it easier for, make it so you can actually compile. And then it's going to send that through the compiler linker, which will create your executable. I'm going to refer to this preprocessor on a regular basis, so I just wanted you to have a sense of what I'm talking about, and we're going to explain what it does in a moment. So this is a code. This is some program code. It's a very simple code that's going to print the value of pi 3.1416 onto the screen or into the terminal. The first part up here is called a comment. This is code that's going to be stripped away by the preprocessor and is never actually going to be processed. When you look at it though, how we know it's a comment is that it starts with this slash asterisk up in the top over here, and then it ends with this slash asterisk over here. And anything bracketed by those two symbols is going to be treated as a comment and is going to be stripped away by the preprocessor. The next set of commands here that start with this pound symbol are called preprocessor directives, and these tell the preprocessor do certain actions with the code. So this first preprocessor directive, pound include, says I want you to include another file into my program. And this, in this case, there's this standard input-output library called standardio.h, which defines functions like printf down here. The standardio library allows us to do very basic input-output operations into our programs, and so that's been written, been tested, rigorously created by someone else, so you don't have to do it. It's great. So what the preprocessor will do, it'll look for some file named standardio.h, and it's going to replace the code with the standardio.h library. The second preprocessor directive, this pound define, says I want to define this word here, this capital P, capital I, as being equivalent to 3.1416f. And what's going to happen is the preprocessor is going to look through the code and go, oh hey, here's capital P, capital I. I'm going to replace this capital Pi with 3.1416f. And then I'm going to delete my directive. I'm going to take it away so the compiler won't see it. This is really handy for if you're going to be defining a value several times, but you only want to, but maybe, let's say you're going to use assign the number 30 100 times, then you realize, oh shoot, I should have done that 40 times. Well, you can, if you use those pound defines, it's a very easy way to make it so if you know you're going to use a command several times, you can define it up at the top of your code where it's easier to find. The next command is this integer main. And so every program, when you see a word like main followed by two open and closed parentheses, that's a function. Now functions have two main parts. First, they have a type. So this integer over here tells us that this function is of type integer, and that means when the function is done writing, it's going to send an integer back out. And since main is the main function that's going to tell the computer when is this program done running, when we get down to this return 0, this 0 will be sent to the CPU to say, hey, this program's done, you don't need to keep running me anymore. So that's just a flag value to say, am I still running or not? Next you've got the name, which says main, and then you've got this body, which is outlined by these curly braces, this top one here and this bottom one down there. Those curly braces tell us which parts of the code belong to the integer main function. Then, inside this function, we're going to have things like variables. Variables, again, have several parts. First, you've got the word float here, which tells us the type of variable that we have. That means it's a floating point number, so it's going to be interpreted with the IEEE standard, most likely. And then we've got the name of the variable, which is this lowercase pi. And then if we want to, this is optional, we can assign a value to our variable immediately with this by putting this assignment operator equals and saying, then we'll put this 3.1416f as the value of the variable pi. The final main thing that I want to talk about here is this function printf. So you see the printf, it's got this parentheses, this is the function. And what it's going to do is going to print the string pi equals, and then it's going to take this, it's telling us, hey, I'm looking for a floating point number, looking for the floating point number pi. It's going to print that 3.1416f onto the screen. So one last note before we stop. Syntax is really important. Computers are dumb. They do exactly what you tell them and only what you tell them. So if there's a mistake, it's your fault. So one critical mistake that students often miss, myself included, this is a $5,000 mistake right here for me. I forgot one semicolon, it cost me that much money. Anyways, so semicolon, it ends every instruction in the program. So here you see this, like, we're defining a variable, assigning it to be the value 3.1416, and now we're done with that command. Next command. All your commands should do this. If you find it weird, a bunch of errors, you've probably missed a semicolon somewhere, and that's the first thing you should check for if your program's not doing what you want it to do.